Let's analyze and solve the container with most water coding problem. We are given an input array height, and it is an array of integers, and we have to return the maximum area of water that the container can store. Each element in the array represents the height of the vertical line drawn at that index. The best way to understand this problem is to look at the example. So here we have an input array height with the values 6, 10, 7, 2, 9, 4, 5, and above we have a graph which represents that array. For example, at index 0 we have a value 6, and on the graph at position 0 we have a bar with the height 6. And at index 1 we have a value 10, and on the graph at position 1 we have a bar with the height of 10, and so on. And now what this problem is asking for is to pick two such bars from the given array. For example, we can pick bar at position 0 and bar at position 2, and they will form a rectangle. The height of this rectangle will be the height of the lower bar. So in this case, the height would be 6. And we will get a rectangle with the area marked on the screen. And we can pick two different bars. For example, we could pick 0 and 3, and we would get a different rectangle. This rectangle height would be 2, and the area would be like this. And in this problem, what we are being asked to do is to pick two bars such that the area of the rectangle formed by those two bars is the maximum one. And that's the gist of the problem. From the coding point of view, what we are being asked for is to write a function. We can call it max area. The input for this function will be our array of heights, and the output will be the maximum possible area we can find using the data in the array. And we are given a set of constraints. What we are being told is the array will have at minimum 2 values, so the minimum size is 2, and the height will be greater or equal than 0, so the values inside array are either 0 or positive. And that's pretty much the entire problem. To solve this problem, we are going to use a simple brute force approach, and the way we are going to do it is as follows. We will have a variable, let's call it max area. We will initialize it to 0, and we will use it to track the maximum so far area of the rectangle we were able to find using the data inside our array. And the way we are going to find all those rectangles is very simple. We will check all possible pairs of the bars on the graph, and for each pair we will compute the area, and if the area of the rectangle is greater than our max area, we will update max area and move on to the next possible pair of bars. And once we exhaust all pairs, what we will have left in the area will be the maximum area we were able to find, because we considered all possibilities, all possible pairs of bars. To demonstrate this, we can show it on the graph. So let's say our left side of the rectangle is the very first bar. So we will start from the left side being the very first bar, and we will have a pointer or an index which will be initialized to the one bar after the current left bar, in which case this will be this bar. And the rectangle we can form is like this. So it has a width 1 and the height 6, because the height is the minimum of the two heights. And we would compute the area. Area is 1 times 6 is 6. We would check whether the area is greater than our max area so far. It is, so we would update that max area, and we would move the right side to the next bar, and we would find another rectangle. This rectangle would be a wider rectangle with the same height. We would compute its area again, compare with the max area, and so on until we reach the last bar, and then the rectangle we could form between the first bar at index 0 and last bar at index 6 would be as I am drawing on the screen. So this would be the rectangle, and we would again compute the area of this rectangle, and this would be all rectangles which have left side at position 0 and the right side all the positions after 0. And once we check all of those, we would move the left side to be the next bar, which is 1, and we would again check all the possibilities for the right side. So the first one would be the bar which is at index 2. This would be the rectangle. We would again continue the algorithm, compute the area, find the maximum area between the current area and the max area. Then we would move to the next bar. The next rectangle would be like this, and so on. So this is the idea how we can use brute force to solve that problem. In terms of code, this algorithm translates to two for loops. We would have the outside for loop, which will be tracking our left side. So this would be the left side of the rectangle, and the inner for loop, which would be the right side of our rectangle. And because we have two for loops, our time complexity would be O of n squared, where n is the size of our input array, and the space complexity would be just O of 1, because we are not using any additional memory. So these are the complexities for the brute force algorithm. The brute force algorithm works, but we can find a better solution with a better time complexity. And in order to do that, let's consider a rectangle. The rectangle has a height h and a width w, and area of this rectangle would be h times w. Since we are multiplying those two numbers, the bigger each of those two numbers is, the bigger the area is gonna be. So with that observation, we can think about the following. Our biggest possible width is when we consider the very first bar and the very last bar. So what we can do, we can have two pointers or two indexes, left and right, and at the beginning of the algorithm, we are going to position them at the left at the very first element, the right at the very last element. This gives us the biggest possible width. And now we will compute the area of this rectangle, and the area will be right minus left times the minimum value of the two bars. In this case, the value of the right is 5, the value for the left is 6. So the minimum will be 5, so we will compute 5 times 6 minus 0, which is 6, which is going to be 30. And then what we would do is we would pick the smaller one. Since we want to maximize the height, we would pick the one which is smaller, and for that value, we would move the pointer in the appropriate direction. So in the case of right, like in our case here, we would move the right pointer to the index 5. And again, we would compute the area, and like before, we need a variable to track the maximum so far area. So we can have a variable, let's call it max area. At the beginning, we will initialize it to 0. And each time we compute the area of our rectangle, we will compare it with max area. And if the max area is less than our current rectangle's area, then we will update max area. So going back to the algorithm, we would move to right to index 5, compute the new area of this new rectangle. This rectangle will be like this, and compare with the max area and move one of those pointers. In this case, the value at the right pointer is lower than the value at the left pointer, so we would again move the right pointer. We would get a new rectangle. This new rectangle would be like this, and we would compute the area, compare with the max area, and once we do that, we would move the pointer again, but this time we would have to move the left pointer because 6 is less than 9. So we always move the pointer which points to the value which is less of the 2. If they are equal, we could move either of them. So it doesn't matter how we code that specific case. So in this case, we would move the left pointer. It would point to index 1 and so on until those pointers meet. And this way, what we can notice is that we are reading the array just one time. So each value from the array we just read one time. And because of that, our time complexity becomes of n when the n is the size of the array, and the space complexity remains of 1 because we don't need any additional memory. And these complexities are better than the ones we had for the brute force algorithm, actually much better because we went from the O of n squared to just O of n. And that's the idea for the optimal algorithm for this problem. Let's write code for our two solutions starting from the brute force. We will start from initializing the max area variable. We initialize max area to 0. And let's also compute the size of the array. With those two ready, we can define the two for loops which we will use in the brute force solution. For the outer for loop, I is between 0 and the size of the array, so we are scanning through the entire array. For the inner for loop, j starts one element after the current I, so j initial value is I plus 1. And with that, we can compute the height and the width of our rectangle. So the height of our rectangle will be the minimum value between height of I and height of j, and the width will be the difference between j and I. With those two defined, we can compute the current area, and the area will be height times width. And we have to update the max area. So in case the max area is less than the current area, we have to change max area. And we can do it using standard max. So we are assigning the maximum of the two values to max area, which is the maximum between max area and the current area. And that's the entire algorithm. The one remaining part is to return max area. And with that, we can see if we can build this code. The code builds with no errors, so we can try to run the tests. And all the tests are passing with no problems. So we have coded the brute force solution for our problem. Let's write code for our optimal solution. We will start from defining a max area variable. We initialize max area to 0, and let's define our two pointers or our two indexes left and right, because in the optimal solutions we are using the two pointers approach. So we initialize left to 0, which is the first element in the array, and the right to the size of the array minus 1, which is the last element in the array. Now we will have while loop, and the while loop condition is that the left has to be less than right, and inside that while loop we will be computing the area of the current rectangle. By the current means the left side is the value pointed by the left index, and the right side is the value pointed by the right index. So let's compute the height first. And the height will be the minimum value of the two, so the minimum between the height of left and height of right. Now we can compute width, which is simply right minus left. And now we have both width and height of our rectangle, so we can compute the current area. And the last part, once we have the area computed, is to make sure to update the max area. And the max area will be the maximum between the current max area and the area of the current rectangle we just computed. After that, what we have to do, we have to move either left or right, depending which value is greater. So we need an if statement. And in that if statement, what we are doing, we are checking whether the value of the array at index left is less than value of the array at index right. And if it is, that means we have to move left towards the center of the array, towards the right side. If it is not, then we have to move the right index. So we are decrementing the right index. And with that, the only remaining part is to return max area. And let's see if we can build this code. It builds with no errors. Let's try to run tests. All the tests have passed, so we have successfully coded the optimal algorithm for our solution. Let's make sure that our solutions are passing all the LeetCode tests. So let's start from the brute force solution. Let's see if this works. It works. Let's submit it. We were able to submit it, but we got time limit exceeded because our solution is O of n squared, and with a lot of data, like in this case, we are exceeding the time allowed for the execution. So let's now see if our optimized solution does any better. We have our optimal solution. Let's see if it works. It works. Let's try to submit. And we were able to submit, and we didn't get the TLE, time limit exceeded. So both solutions worked, but the brute force is giving us TLE because its complexity is not good. This is the end of this solution. The source code is available in the GitHub repo shown on the screen.